Today we're talking about the evolutionary Pi Model 830 multifunction calibrator and diagnostics tool. As a multifunction calibrator, it works for milliamps, easy check switch, toggles between 4, any other point, and 20 milliamps. Double click our easy dial knob to get into our double click menu. Choose your functions: milliamp, voltage, source pH, thermocouple, ohms, RTD, frequency, and back to milliamps. We'll go into thermocouple. You can choose between units of degrees C or degrees F, or choose your thermocouple type. When you're done with the menus, simply exit. Those are all of the source functions. Read functions are very similar. Thermocouple, ohms, RTD, frequency. Now we add pressure, back to milliamps, and voltage. You'll also note on the display it shows you where to connect each of the wires for each of the functions. Also comes in this carrying case with a built-in tilt stand, which is easily removed to access the battery compartment for easy 1-minute battery changes of the 4 AA batteries. Here we have the Pi Model 830 set up to power up a 2-wire temperature transmitter. In this case, it's an RTD transmitter. What we're doing is simultaneously supplying 24 volts out from the calibrator to the transmitter while reading back the 4 to 20 milliamp signal. Simultaneously, we're sending out from the calibrator a simulated RTD signal into the transmitter. In this case, we're spanned 0 to 200 degrees C. 200 degrees C, 20 milliamps into the transmitter. 0 degrees C, 4 milliamps out of the transmitter. And at a mid-scale of 100 degrees C, we should see approximately 12 milliamps on the transmitter. Here we are using the Pi Model 830 as a transmitter. Our major competitors cannot do this with their calibrators, kind of unique to Pi. What we're doing is we're taking loop power supply coming into the calibrator using a thermocouple input. There's our thermocouple temperature, 24.8 degrees C, and we're simultaneously acting as a diagnostic transmitter. We're showing you the loop current, which right now is 5.987 milliamps. Supply voltage in the loop, 19.4 volts. And right now we have a loop load of 264 ohms. That's my power supply, plus I have a 250 ohm load resistor. As we vary the temperature coming into the thermocouple, we see the rise in the temperature and a corresponding rise in the current signal. In order to configure this to act as a transmitter, put it into the read mode, select thermocouple, and then you tell it, I'd like to store my 0 point, which in this case 0 degrees, 200 degrees is my span, and then when you put it in the middle position, it automatically acts as a transmitter. Not only that, but with the loop scope running, we're showing the loop diagnostics. If you had a problem in the loop where there was too much load resistance, not enough voltage, you wouldn't be able to get the correct milliamps coming out of the transmitter, in this case the calibrator. An excellent diagnostics tool. Here we have the Pi-Cal Model 830 connected up to the pressure module up to one of our hand pumps. This happens to be an absolute pressure module. We'll just change the pressure slightly, get it to exactly 100 kPa absolute. There we go. Plenty of accuracy and resolution. Here we have the Pi 830 set up to power up a transmitter and drive a whole loop while monitoring for any current leaks in the loop. Right now we're set at a mid-scale 125 degrees C, seeing around 12 milliamps in the control room, and we're showing 11.973 milliamps. I've just switched in a wet sponge, which is simulating a flooded junction box in the loop. Now our control room is seeing around 17 milliamps. We're also showing 16.7, give or take, milliamps. We're telling you of that current that's running in the loop, 4.88 milliamps is current that's leaking in the loop. No other calibrator can detect this. Once it's detected, you go find the leak, empty the flooded junction box, control room goes back to 12 milliamps, we go back to around 12 milliamps and show you there's now 0 milliamps of leak.